I'm going to cover 3 ways to conduct t-tests using Jamovi. We'll look at a one-sample t-test, a paired samples t-test, and an independent samples t-test. I'll start with the one-sample t-test. What if I wanted to test if forward digit span, which you can see here in the column I've just highlighted, is different than a population score? A single mean, let's say 6, which is the value for digit span forward in the Wechsler Adult Intelligence Scale Test Manual. So first I'll look at my data at what I'm trying to do. The design here is a single column of numbers, a single set of observations versus one value. So under t-tests, that's a one-sample t-test. I'll take digit span forward, put it in as my dependent, and I need a test value in the bottom left of the screen. That hypothesized test value is 6. I'll ask for an effect size. I'll ask for descriptives. And here's the output. On the bottom, you can see the descriptive stats. The mean in the sample was 6.60 with a standard deviation of 1.32. We're testing it against a hypothesized population mean of 6, which you see on the top. And this is the output from your t-test. None of this output goes into an APA paper. You use it to write a sentence. What to look for here is you want the statistic, the test statistic, to be fairly large. T tends towards 0 when nothing's happening. And it can be 2, 3, 4, 5, 10, 15 if something is happening. You want the p-value, our measure of reliability, to be very small, less than 0.05. Right? So if there's a significant or reliable difference, the probability that it won't happen again is small. Think of the p-value as the number of times your car doesn't start when you turn the key. You want it to be tiny. You want the effect size to be fairly large. It's the number of standard deviations of change, Cohen's d. Cohen's d isn't whether your car started. Cohen's d is how far you were going to go in the first place. If you were only going 0.1, 0.05, 0.04, if you're only going half a block or 2 houses down, it doesn't matter if your car was going to start. But if you're moving 0.5, half a mile, a d of 1, a full mile, it matters a lot if your car would start. So d effect size is how far you were going to go with it. And you can see this in medium effect size of 0.45. Let's look at the next way to use t. In a paired samples t-test, I'm going to compare forward to backward, both of which are taken from the same people. Right? Participant 3 has scored 4 forward, 5 backward. 4 scored 7 forward, 6 backward. Is forward different than backward? T-test, paired samples. I'm going to put forward and then backward in as a paired variable. I'll ask for effect size and descriptives. Very similar output. You can see the descriptive stats at the bottom, the means and standard deviations. Forward span averaged 6.6 in the sample. Backward span averaged 5.83. Standard deviations are roughly equivalent. That's important in t. T assumes homogeneity of variance. It assumes that the standard deviations are roughly the same size. Then finally, the t-test output at the top. You can see it lists the pair you're comparing, forward and backward. The value of students t is 5.5. Our degrees of freedom, 59, so that's 60 pairs minus 1. Our p-value, reliably, it's a reliable effect. P is less than 0.001. It needs to be less than 0.05. And Cohen's d, the effect size, is about 0.7, so it's a medium to large effect. Again, this isn't what you put into your paper, it's what you use to write a sentence that goes in your paper. Third way to use t is to compare different people. So one sample compares a whole column of numbers to a single expected value, a population mean or normative score. A paired samples t-test compares 2 scores that come from the same person. An independent samples t-test compares a single score that comes from different people. So if I wanted to compare backward digit span for males and females, you can see the first 2 females scored 5, the first male scored 6. They're different people. Right? Gender marks my different groups. Digits backward is the score I'll work with. So I will take analyses t-test. I'm going to run independent samples. Gender is my grouping variable, and it wants something that's nominal. Notice how it has the three little circles there. That means it wants a grouping, not a measurement. And we're going to take digits backward and put it in as our dependent. Ask for effect size and descriptives. And the output again looks very similar to the other t-tests. You can see the descriptives at the bottom. There were 12 males averaging 5.58 and 48 females averaging 5.9. You can see the difference here. T can be positive or negative, whether we're talking higher or lower. The statistic is 0.0771. But since it's such a large sample, well, actually it's not significant. See, the P is 0.4. That means 40% of the time this wouldn't happen again. Right, so 5.9 versus 5.6, essentially, these aren't different. Right, that males and females, backward digit span, are essentially the same. It's not a reliable or significant difference. We can see this P here is not 0.05, it's 0.444. And those are the three ways to use T in any statistics package, and I just walked through them for you in Jamovi.